I'm going to do 60 seconds worth of announcements before we begin today's episode. Pasadena, California, October 22nd, 2017. The Data Science Conference is taking place. I'll be there and you'll hear more about the event as the time gets closer. Now, I'm helping out recruiting people specifically for the AI track. I want to make sure there's a good representation of all the topics in AI. That may mean we turn down a few good talks that are an overlap with the speakers they already confirmed before I got on board, but I'm specifically looking for people in reinforcement learning and multi-agent systems that might want to give a talk. Please shoot me an email, kyle@dataskeptic.com, if you're interested, and I'll help with the process. Also, FarCon that I announced last week is sold out. I might be able to help you get some tickets. Shoot me an email if you're interested. Also, their training sessions just opened up this week, so try and get over there as quick as you can and sign up for one of those. I'm going to be giving one. FarCon, if you're going to be in Minneapolis, Minnesota, and the Data Science Conference, if you're going to be in Pasadena, California. Links to both in the show notes.
Data Skeptic is the official podcast of dataskeptic.com, bringing you stories, interviews, and mini episodes on topics in data science, machine learning, statistics, and artificial intelligence.
Tony Beltramelli is the founder and CEO of UIzard Technologies. He specialized in machine learning during his graduate studies at the IT University of Copenhagen and ETH Zurich. His research work on the application of deep learning was featured in international media such as Wired, Forbes, The Huffington Post, The Next Web, Gizmodo, and more. Tony, welcome to Data Skeptic.
Thanks for having me, Kyle.
So Tony, to begin with, I'd love it if we could just maybe introduce the problem you're solving for a little bit. It would be surprising if any listeners didn't know the basics of, the web and that it's all HTML, but I don't want to take for granted that people know the real ins and outs of making a website. So how does the process usually start going from the designer who says what it should look like to the actual implementation?
Designer will typically design a bunch of screens, a bunch of user interfaces, and then he will ship this to developers. Front-end developers will have to do two things before they can actually ship the app to people. The first thing that will happen will be to transform the design mockups, the design screens that the designer made, and convert this into a front-end code. So it would typically be HTML, CSS for websites. It will be XML for Android and iOS. And then once this is done, developer will start implementing the features and all the nice functionality that people will use and the logic. But it's kind of broken because as a developer, you really want to focus on doing the fun things, the logic, coding the animation and the transition, but you don't want to spend so much time handling all the CSS, HTML type of thing.
In terms of designers, I guess each one might have their own process that could be different, but in general, what are their tools? Are they working in Photoshop and creating just images of pages, or is it something a little bit more structured?
It depends on designers. There is right now the two hot tools, as I would say, will be Photoshop and Sketch. So Sketch got quite a lot of traction recently, and designers tend to prefer Sketch over Photoshop nowadays. So it really depends on designers and their habits and so forth. So developers also have to take, they have to know how to use each of the software when they work with designers.
So there's a lot of work that goes into that translation then from the designer's work to the actual code version of the website, and that involves many people. So I can easily imagine how that gets to be a slow process. There has to be a lot of planning involved. Let's get into what pix2code does and the functionality it provides its users.
Pix2code is really just a research project that really scratched the surface. And so the idea is given a user interface mockup screenshot as input, which is really just a picture, the goal is to generate front-end code, and it could be HTML, CSS, or other language depending on the platform. But what we really tried to do with this project is to solve the issue of a given tool that the designer used to code, basically. So the goal is, because we can actually use a picture, an image as input, then it doesn't matter if the picture has been produced from Sketch, from Photoshop, or from really anything else. If a designer tomorrow decides to use Microsoft Paint to create his user interfaces, then if we can still generate code from it, then that would be a big deal.
So I think most people are aware of really big advancements in image recognition in the last 5 to 10 years. We now have systems that, with deep learning, do very impressive object detection. And I don't want to say that those results aren't impressive, because certainly they are, but it seems to me that the problem you're tackling is like an order of magnitude more difficult, because you're not just saying, is there a label present? You're actually producing something structured. Do you see it the same way, or is this a more natural extension of the object detection systems I've seen?
Well, actually, the neural network architecture is very inspired completely from work that have been done in image captioning, for example. So you've probably seen those research where you would feed a scene into the model, and you will output an English description of the scene. So let's say a black cat walked down the street. And in our case, the problem is pretty much the same. So instead of trying to understand a scene, we try to understand a user interface. And instead of generating English description, we generate code. But the architecture is very, very similar to this problem. And we actually tackle the problem the same way.
Yeah, let's talk a little bit more about the architecture in terms of what layers and activation functions and these sort of choices you had to make. What does pix2code look like under the hood?
We have three main components. The first component is a convolutional neural network, which is a state-of-the-art when it comes to understanding visual inputs. So this convolutional neural network will process the input image and output its own representation of this image. Then we have a recurrent neural network, which is made of LSTM cells, which are basically long, short-term memory cells, which is a state-of-the-art when it comes to processing sequence of data. This layer is actually in charge of handling code itself, because the code is basically a sequence of tokens, a sequence of characters. And finally, those two networks are merging the output, and this output is fed into another LSTM recurrent neural network stack, which is in charge of learning the correspondence between a given code token and the associated image representation.
Yeah, so you've got image recognition and then some sequential things and then like a merge layer. Is that a fair way to sum it up?
Exactly, and once again, it is really the same architecture as the work that have been done in image captioning.
So what is the output of pix2code? Is it HTML or is there another maybe domain-specific language in the middle?
So the output is actually not directly HTML and CSS, because the search space will be just insanely big, for example. So HTML CSS would mean that you will need to learn every single character. And as you can imagine, the vocabulary size will be quite big, and it will be hard to train a model to generate such a thing. And so the way it's done is that we design our own domain-specific language in between. And so the model, our neural network, learn to generate code written in our domain-specific language. And this domain-specific language is a simplified language which helps us to describe user interfaces. So you will have keywords such as button, label, container, stack, this kind of things. And so the vocabulary size will become much smaller, but it will still allow us to keep all the high-level concept of what a user interface is made of. Once the network can generate this domain-specific language program, we can actually just use standard compilation design to turn this into HTML, CSS, for instance, for websites, or to turn this into XML for Android or iOS applications.
Ah, nice. That's to me that was strategic when I read that part of the paper, because then I thought, it makes it a generalized tool. If I want to use pix2code and I'm creating, something like a swing Java layout, I don't know why I'd be doing that, but that might not be a default option. But as long as I understand your domain-specific language, I can just implement the basic mapping to whatever format I want it in. It makes it kind of general. Was that the motivation, or was it more about giving a level of specificity to the DSL that you thought would be learnable?
This is actually a twofold benefit. So as you said, one benefit is really to make the problem more accessible for a machine learning algorithm like the one we used. And on the other side, you also have really nice benefits if we want to provide this technology later on to people. Because, we can imagine that if we can scale the technology and somehow tomorrow there is a new hot language that developer want to use, we don't want to have to retrain the model from scratch. We can just write a compiler from the domain-specific language to this new hot language, and everything will work.
We've made the comparison here a couple times to captioning, which I think is a very good comparison. But captioning, as much as the end of the sentence relies on the beginning of the sentence, they're connected. So we want technologies like LSTMs to be present. There's something a little bit harder, it seems to me, about your project in that everything about a layout tends to be encapsulated. We think of things as being components that are nested inside one another. So if this were, I know you're not going directly to HTML, but if you were, you'd have, some tag open, like this is a div that has to have a corresponding close, and it needs a sort of certain symmetry to it, which is seems like a hard problem for neural networks. Can you talk a little bit specifically about that challenge?
Our domain-specific language still has this concept of container, so it will actually learn to open tags and close them. It just doesn't open an HTML tag, but it will open a bracket. And then it will need to know when it is time to close the bracket. This is what LSTM is so powerful. You can actually learn long-term dependencies, and such that, something was open a long time ago, now I need to close it. So it actually works with LSTM the same way. The only challenge is, if you want to really do that efficiently, is that you need to give a time window in order for your model to be able to learn long-term dependencies. And by a time window, I need really an internal state so that the LSTM can, in a way, remember what is, if seen in the past, some time step ahead in order to be able to close the tag. It will basically work the same way if we were generating HTML directly, because LSTM can actually model this long-term dependency.
There's been a lot of attempts I've seen over the years. I've been in and around the web since maybe the 90s, so I've seen a lot of different functionality and tools come and go and the evolution of the whole stack. And there's been a lot of attempts to create tools that could produce WYSIWYG code. That's what you see is what you get. That I can go in and draw something out and then render it as HTML. And invariably, now obviously I haven't reviewed every tool out there, but the majority of these produce uninterpretable code. It's just a mess of random tags. It might render and look correct, but it's sort of unusable almost if you want to go and make edits as a developer at the code level. Do you face a similar challenge in the output of pix2code, or does it come out structured in an intuitive way?
Well, that's actually a question I have quite a lot, because as you said, code generators have been here for a long time, and most of them actually failed to get attention. And so the reason for that, as you said, is because the code is just ugly and developers just don't want to touch it. Pix2code, once again, is really just a research project because of a structure in which we don't generate code directly. Because we have this intermediate language and then we compile it to the final code. Then in the compiler, you can really control the quality of the code you're going to output. So the domain-specific language in between can be as ugly as possible. It doesn't really matter, because the developer at the end will only touch the compiled version of this domain-specific language. And since it's a compiler, you could basically inject any type of rule into this compiler. Let's say I want to use tabs over spaces, or I want to use this type of indentation, and so forth and so on. You could actually argue that because we use a compiler, you could really choose how the final code will look, instead of relying on pure generation, which can be out of control.
Can you tell me a little bit about the training set you used to create the initial model?
Yes, so in this research model, this research paper, the training set is actually artificial, is synthesized, and so the reason for that is the goal was not only to generate code for HTML, CSS, but it was really to see if we can actually reuse the same model for different platforms. And that's why we actually synthesize our own data in order to control the quality of the output and be able to achieve our multi-platform code generation goal. So the reason for that is that there is plenty of websites we could have used online as a training set, but it would have been really hard to get the corresponding data for Android or for iOS. So we decided to go for synthesizing our own data so we can control the quality, test that the model can actually generate the code for that, and then in a next version of the paper, an iteration on this research could involve some real-world data, as I would say.
There is something exciting about the existence of the web and the fact that I could, use a program that, I guess it's, WebKit. I could render any web page I find, and I could also look at its source code. So you have this, on the surface, it almost looks like a large data set, but that, of course, leaves out Android and some others that you commented on, which is, I could see could be frustrating. In terms of developing more training examples, is there something that's required that you have a good sampling from the various forms of UIs? In other words, would you overfit if you trained on too much web data?
Well, actually, if you look at research that I've been in, for example, object classification, actually there is a paper from Google that was published last week, I believe, where they show that the more data you fit in, the better the model gets, with quite dramatically. And so I would actually tend to argue that the more exotic user interfaces we could feed in, the better the model will be able to generalize to exotic user interfaces. It could behave differently for all type of data. I mean, user interfaces are quite complex, they're quite rich, they have hierarchical concepts, so it might not scale as well as data scale for object recognition and object classification. So I guess further research will be able to answer this question.
In the paper, I know you report getting a 77% accuracy. Can you tell me a little bit about the loss function you're using and how you measure that accuracy?
We really treated the problem as a classification problem. The loss function is really like a multinomial cross entropy or a multi-class log loss, like really classic stuff. Mm-hmm. The output layer contains n cells and n corresponding to the size of the vocabulary of our domain-specific language. So we can actually perform classification because we have this fixed size vocabulary. Since we actually treat the problem as a classification problem, we can actually just measure the accuracy as correctly predicted token and wrongly corrected token. And so for each wrongly corrected token, this is counted as error. But this is not it, because you could actually imagine that if the size of the generated string of code is longer or shorter than the expected string of code, you will also need to account for this difference of size as error. So this is the two things that goes into the performance metric. The difference of size between the expected string and the generated string and the individual token pair correctness.
Yeah, so I essentially have to get symbol by symbol match between what's predicted and what's expected.
That's correct. And then on top of that, you will also account for the difference of length between the expected string and the generated string.
Yeah, that's important. So I might produce a representation that's close but longer because it has something extraneous. So you want to penalize on that, but not as harshly as having things that are maybe incorrect symbols.
You could imagine that for whatever reason, the beginning of the file is absolutely correct, and everything, let's say the 10 first lines match exactly what you expected, but for whatever reason, your model generated 5 extra lines of code, which are totally not wanted. Then you want to penalize for that.
And then I'd like to explore the architecture a little bit more as well. We talked about how there's the convolutional neural network that's finding, some representation at the image level, and the RNN that's learning, as I understand it, kind of the sequence of symbols and then tying those together. Is one of those harder to train than the other?
In our case, because we have the convolutional neural network producing an output connected to the output of a LSTM stack, and the two connected to a second LSTM, then the whole model is actually differentiable, which means that I didn't have to train the LSTM separately from the CNN and so forth. I actually trained the whole thing at once, end to end.
Got it. So you can do backprop across both those kind of sub-modules, if you're willing to call them that. Is that right?
That's absolutely correct. The whole thing is differentiable end-to-end, so I can just do backprop over the whole thing and train everything at once.
Very cool. As far as I can tell, this is really the first step in exploring how deep learning can be used in user interface design. Was there any prior work, or is this a pioneering effort?
There is plenty of work that have been done into generating programs automatically using deep learning. Mm-hmm. This is actually the first work, to the best of my knowledge, who is actually using visual input to do so. Previous work, I've actually been trying to generate code from a textual description, from a specification, or from symbolic requirements. But this is, to the best of my knowledge, the first work that actually tried to generate code from visual input using deep learning.
Yeah, I think it's a really interesting step in a certain direction. I imagine there's going to be a lot of inspired work to follow on because it's a very useful function to serve in the world, can really speed up a lot of development processes. And in fact, you mentioned a couple of things in the paper about next steps. Can you tell me what you're most excited about exploring next and where the research will go?
The most exciting next step will be to actually use a generative model to try to either replace completely the current pix2code architecture, which is extremely basic, or support it. So combining the power of the very simple image captioning inspired architecture with a generative model, or just use a generative model directly. Those generative models have been doing extremely impressive work recently, and have been also used for sequence modeling as well. So you could imagine using this to generate code in a similar way, but with a totally different architecture. And I'm actually really excited to see how it could of future research will build upon that.
One of the interesting challenges I wanted to get your thoughts on, not to think too far down the line, but of course most websites and even Android, iOS apps, they have this property of being, I think they call it responsive design, that depending on the screen size and even the rotation of a tablet and things like that, they're going to render a little differently. Do you think that'll be an extra challenge, or will a large enough network with a big enough training and some tweaks to the architecture be able to easily solve that aspect of the problem as well?
Well, actually, responsiveness is a little bit more complex because it really depends on, the user interface layout will change depending on the screen size. So there is a dynamic aspect to it. And so unless you can somehow feed a sequence representing the transition from a big screen to a smaller screen, it won't be able to learn how to model that relationship.
But in theory, I guess maybe we could build a different network for all of the shapes and sizes, and there's no reason they couldn't all equally learn to the context you train them in, and then have some mechanism for combining those or something. I don't know. I'm just thinking out loud a little bit.
Well, that's actually a good point. You could actually imagine having let's say 3 inputs. You could imagine having one input, which will be the user interfaces in a big screen, one input, which is the same user interfaces for a smartphone size screen, and a third one for tablet. And then somehow the internal representation of the model will be able to find relationships between those 3 different inputs and somehow be able to model this responsiveness. But yeah, that would be quite an exciting future work, actually.
Yeah, there's I think a lot of opportunity in this space, and I think we're going to see tools like yours emerging very quickly. They fill a big need. So many people are creating technology that, and this is I don't want to call it a slow step in the process, but if nothing else, a tedious one, I suppose, at least for the people implementing some of the, very down and dirty, slice up the image, take pixel measurements. So how long do you think people who do that sort of nitty-gritty work have to worry about their employment?
Well, I think they will have they shouldn't be in any way concerned about being unemployed, because really this kind of tool will really firstly assist people, because right now this type of model really generates a template of the page. But then if you really want to be able to have your specific graphical element into this, you will still need people who will know actually how to implement them into either by code or by cutting the pixels directly from the Photoshop or the sketch file. So there will still be plenty of work for front-end developers in the future, that's for sure. Yeah,
that's my impression as well. I think this is just like taking someone from a hand saw to an electric saw. It's just giving them the ability to work faster and better.
Exactly. Assist people, make their life a little bit easier when they're implementing applications.
Let's take a break from today's episode and talk about our sponsor, Periscope Data. If you've got a data team, you've got to check out Periscope Data. Specifically today, I wanted to highlight one of their features, what's called the Cohort Chart. Some people call this a waterfall chart. This is where you want to compare different groups of people over time, maybe new customers that joined by a certain month, and you want to learn something about them. What are their buying habits or their frequency with which they return to your website? The older a cohort is, the more you know about it. Yet the newer cohorts are the ones you're most interested in. If you keep track of any performance metric that makes sense to group by cohorts, you need to look at charts like this all the time. There's no great way to write a query that does a pivot table. That's not part of SQL, really. But if you can write the query that pulls out your metrics from whatever relational scheme you have and it's organized by cohort and by month, their system's going to instantly convert that into that beautiful chart you're picturing in your mind, the one that month over month shows how the trends in performance play out. I do it now in one click, right inside Periscope Data. Creating these quickly and sharing them easily with your collaborators is going to save you a bunch of time. Get started at periscopedata.com/skeptics. One more time, that's periscopedata.com/skeptics. So the source code that goes along with the paper, by the way, the paper will be in the show notes for anyone who wants to read it, as well as the GitHub repo that's attached to that. Can someone pick that up and run it and do some experiments on their own? Or tell me about the opportunities there.
Well, actually, not yet. So right now, since the paper have been submitted for a conference, I'm waiting for answer from this conference, and then I will publish the source code, and I will also publish the data set. So the idea is to I've benefited plenty from the open source community and open access to science data set. And I want also to provide this data set for free for anyone to build upon this project and experiment with it. And the source code, as you said, people will just be able to grab it and run it and reproduce the result that the paper is claiming.
So I think this is an exciting first step. I definitely want to be keeping an eye on where you're going with this line of research and where your company UIzard goes. What's the best place for people to find you and follow you online?
So people can actually check our website, uizard.io, and this is where we're going to actually push our research and our effort, so people can follow up on what we're building.
And just to make sure everyone's totally clear on the audio podcast, that's UIzard for UIzard. And then lastly, to wind up, I know I asked you on to talk about pix2code, but in doing the prep work, I saw a number of interesting other projects you've worked on. I wonder if I could ask you about to describe what deep spying is.
So deep spying was the title of my master thesis, which goal was to actually predict a sequence of character that a person might have typed on a keyboard by analyzing the motion of a smartwatch they might be wearing. So the idea that when someone is wearing a smartwatch or any type of smart wristband, there is typically a motion sensors like gyroscope or accelerometer, which record the motion of the wrist. And so the idea that from the motion of this wrist alone, can we actually predict what the person was typing? It could have actually big implication because people might have their smartwatch on when they are typing the PIN code to withdraw money from an ATM machine or unlock their phone and so forth. And so the idea was to see how much information you could extract from the motion alone.
Well, Tony, I hope you get some Hollywood money optioning the idea for a film, because this is a wonderful and scary idea. How afraid should people be that their smartwatches are compromised and they might unintendedly giving up their PIN number?
People shouldn't be so scared. It's really, once again, a research project to see what's possible. And the results show us that it's possible to extract quite a big amount of information. But to the point that someone will be able to use it against you, I think people shouldn't be scared.
Yeah, I think that's a good tale. I like the research I've read so far from you on deep spying, in that it's raising a good question. You know, we should be asking, what can machine learning do and what can't machine learning do? And if we're not knowledgeable about the field, it's easy to fall into being afraid of what's possible. Because, yeah, could a smartwatch be compromised? I absolutely believe it could. And they could be reading all those sensors. But just how revealing are those sensors is a difficult question to answer. So I'm glad you were looking into this.
Exactly.
Well, Tony, this has been great. I want to thank you so much for coming on the show.
Well, thanks a lot for having me, and I hope people are gonna keep being up to date with all the exciting work happening right now in machine learning and data science. It's a great time to be alive, I have to say. A lot of exciting things is happening right now.
Totally agreed. Yeah.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.